Okay, so in this video, we're going to find the volume of composite figures. So we're going to break up the figure into shapes that we do know how to find the volume for. So let's move on to the first example. So example 1, find the volume of the silo pictured below. So right here is a figure of our silo. So when working with composite figures, you want to identify what figures are contained within this composite figure. So straight away, I can see two different figures. First off, we have a cylinder right here. And on top of that cylinder, we do have a cone. So to find the volume of this silo, we're going to add the volume of a cylinder and the volume of a cone. So let's start by finding the volume of this cylinder over here. So we're going to use our formula for a volume of a cylinder, which is denoted by volume is equal to base times altitude. So base, once again, is the area of a base, and the base of a cylinder will be a circle. So we're using area of a circle, which is denoted by pi r squared. So notice in this figure, we are not given the radius. Rather, we are given the diameter. So in order to find the radius, we would divide 12 by 2, which is 6. Which means when we plug in our information into this, we're using pi, which is 3.14, times 6 squared rather than 12. And of course, we're multiplying that base by our altitude, which is 30 feet. So when you go ahead and simplify that, you will get 300 or 3,391.2 units cubed. So that is the volume of this cylinder. So all we need to do is go ahead and find the volume of this top portion, which is the cone. So we're going to use the volume of cone, which is given by 1/3 of our base times altitude. And once again, our base will actually be shared by the top portion of our cylinder. So once again, our radius is not 12, is 6, so half of the diameter. So we go ahead and put this information in, and we get 1/3 times pi, which is 3.14, times 6 squared, and our altitude in our cone is 8 feet. So let's go ahead and multiply that out, and we should get 301.44 units cubed. So there's a little error in this slide. It shouldn't be units cubed. We're actually given feet. So both of these should be feet cubed. So when you go ahead and add those two up, so we're adding 3091.2 plus 301.44. At the very end, you should get 3692.64. So once again, that's 3,692.64 feet cubed. And I don't believe I have the solution written on there, but to find the volume of this total area, we are just adding the volume of the cylinder and the cone. So go ahead and write this down. After you write it down, you may move on to the next video. Oh, and look, we actually had the volume, so it's approximated. So there we go.